वेलकम एवरीवन टू द बेस्ट फ्रेंड कन्वर्सेशन TBC। आज की इस वीडियो का टॉपिक है कलेक्शन इन जावा पार्ट 2। कलेक्शन एक बहुत बड़ा टॉपिक है तो उसको पार्ट वाइज हमने डिवाइड करके यहाँ पे डाला है। सो इट्स अ पार्ट 2 वीडियो एंड द कंटेंट ऑफ टुडेज वीडियो इज हायरार्की ऑफ कलेक्शन फ्रेमवर्क, ArrayList, LinkedList, Vector, difference between ArrayList and LinkedList, and last but not the least ArrayList versus Vector। तो चलिए शुरू करते हैं अपना पहला टॉपिक, hierarchy of collection framework। As we know, the collection interface itself extend a table interface, and all the other interfaces like list, queue, set, dequeue, these all extend the collection interface. But the classes today we're gonna cover is ArrayList, LinkedList and Vector, and these three classes implements the list interface। तो चलते हैं इस वीडियो में आगे। So our next topic is ArrayList। ArrayList implements the list interface. As we know, the all interface like list, queue, set, these all interface extend the collection interface, and the classes like ArrayList implements the list interface. ArrayList maintain the insertion order and is non-synchronized. When we add any element in the ArrayList, the output of the ArrayList will be same as the insertion order in the way we enter the element, and is non-synchronized. That means it is not a thread safe. ArrayList can dynamically increase or decrease the size. That means ArrayList can increase its size and can decrease its size based on the how we entering or removing the elements. The manipulation in ArrayList is slower due to the shifting. When we added or remove any element in the ArrayList, it takes time, it's slow as there is the shifting of the bits, that is memory location happened. It required wrapper class to create ArrayList, not primitive type. What we want to say here that when we create an ArrayList, we require to have our wrapper class. We cannot create our ArrayList with the help of primitive type. For example, if we want to take an int type ArrayList, we have to take its wrapper class, that is integer, or we can create with the help of objects, or we can create with the help of non-primitive type class like string. So what is linked list? Linked list implements the list interface of collection framework. As we know, list interface itself extend the collection interface, and the class linked list implements the list interface in collection framework. It provides linked list data structure. So linked list data structure is a data structure where the node have the memory location of the next elements and having itself elements. So it's just look like the linked list data structure. It can store the duplicate elements. That means we can store the duplicate elements more than 2 times or 1 times. And manipulation in linked list is fast as no shifting is required. When we add or remove any element in the linked list, there is no shifting of the bit happens, so it is fast in comparison to ArrayList. Next is Vector. So Vector is synchronized, that is thread safe. Vector is a legacy class. We know Vector from very initial days of the Java. It's a legacy class, that's why. And Vector double its size when the number of elements exceeds from its capacity. When the list having list is defined with some size and the number of elements exceed its capacity of the size, the vector double its size. For example, if we have the size for 5 elements and we have added the 6th one, then the vector size will become 10. It will double its size. Vector is slow because of synchronization, as when one thread is executing a piece of synchronized method, then the other thread might wait for that thread to complete the execution first. That's why the vector is slow, as it is thread safe, and when one method is execute from the thread, then the other thread might wait to complete the execution for the first one. So what is the difference between ArrayList and LinkedList? Now ArrayList uses dynamic array to store the element, and LinkedList uses doubly linked list to store the elements. As you know, the manipulation in ArrayList is slow because of the shifting required, but in LinkedList the manipulation is quite fast, as there is no shifting required. Now ArrayList, why we use ArrayList? ArrayList is better in storing the element, and LinkedList is better in the manipulation of that particular elements or manipulation of the data. So both ArrayList and LinkedList are good in their own ways. So ArrayList is better in storing the elements, and LinkedList is better in manipulating data. The memory location for the elements in ArrayList is contiguous, but in the case of LinkedList, it is not contiguous. Next is what is ArrayList and Vector. This is our last topic of video part 2. So ArrayList is not synchronized and Vector is synchronized. That is, Vector is thread safe and ArrayList is not thread safe. ArrayList can increase its size up to 50% when number of elements exceeds its capacity. So we know when the number exceeds the particular given size, number of elements exceed the particular given size, the array list increase its size up to 50%. But in the vector, the size will become double, that is 100%. So when the number of elements exceed its capacity in vector, the vector increase its size up to 100%, that is exactly double. ArrayList is not a legacy class, vector is a legacy class. ArrayList is fast as it is non-synchronized, but vector is slow because of synchronization, and we know what is non-synchronization and synchronization. So here we end up our collection in Java part 2 video. Thank you for watching this.